Okay, I'm not going to. Hi, I'm Armando Stellato. I have a double hat here. I work at the University of Rome Tor but I'm also consultant for the FIU, Food and Agriculture Organization of the United Nations. I'm not going to talk about something that is easily benchmarkable, but this is the perspective from the developer of our end user application, and about it, since the objective of LDBC is also in general about promoting graph technologies in big data and their use in general. I'm going to talk about something that is driving me mad when I think about interoperability and the scaling of these technologies. Okay, just a bit of history. Okay, with the FIO hat now, we had in 2004 this, at those times, big thesaurus, Agrobook, which is a big cultural vocabulary developed by FIO. It has 32,000 concepts in up to 22 languages for roughly a total of 6 million triples, so not something very big now. There were a global group of terminologies. There were no existing standard for thesaurus. There were no SCOS and not even SCOS Excel, but they needed something like that. And so there was no existing tool that was meeting the needs of FIU. So in the context of the NEON project, they came out with what was called initially a sort of NEON Lite, a tool which was really customized around this Agrobook. And it was called Agrobook Concept Server. They put together the technologies that they had at that time, you see in Protégé API and so on, and they developed a custom model for modeling thesaurus. Soon they discovered, the tool initially had a lot of appreciation, but so it was, let's say, sold to the other departments, and also other organizations started to have interest in that tool. But soon, with the appreciation, came also the limitations. The system couldn't support other people's stores. It was totally glued to the Protégé API. There was still this HAL model. In the meanwhile, SCOS was out. There was, there was no import for other methodologies. Complicated export because the system was still pretty tied to a specific vocabulary, which was comprising Agrobook and other target datasets. No support for alignments, while Agrobook was soon aligned to a dozen of other vocabularies, and no support for Sparkle. So, in 2010, more or less, the idea of a VocBench2 came out, and I was working with them at that moment, and I proposed to let's say, find this perfect marriage. We had VocBench with some re-engineering to be done, but a big user community working on it, so the user interface was pretty stable and with a lot of features. And on the other side, in my university, we had semantic Turkey with a tool which was, okay, in my opinion, quite well engineered, but we had no big user community, and the user interface was never keeping up with the news that we were putting together. So this was a perfect marriage. I was proposing semantic Turkey as an RDF backend for VocBench, and the objective was to have OSGI Open Service Gateway, so to base the system on OSGI, to have open connectivity, most notable RDF middleware, people storing technologies, and native support for SCOS and SCOS Excel. The objective for the version 2.0 was to leave the user interface mostly as it is, and just rework the whole to make it compatible with all these technologies and to allow the use of different vocabularies. This is more or less the architecture. I will not spend too much time on this slide. By the way, we would say that roughly the two big boxes here are the data layer, which has an abstraction layer over different technologies which can be plugged through OSGI. And then we have a service layer, again with an extension layer. VocBench in this sense is an extension of semantic Turkey in that we have services which have been developed specifically for VocBench and plugged again through OSGI for the general RDF service interface. And then we have the upper layer that is completely specific to VocBench in this case, and it's a server written with, through the Google Web Toolkit. It is managing mostly the user interface and also the user management. So here we have this system. It's a web application, collaborative web application for. It mainly uses COS Excel and is able to also accept thesauri written in COS. We are planning for the future to manage also at a certain level also out management, to cover out management. We have also a very specific workflow for very detailed workflow for going through the publication of different concepts. You can have a concept promoted, suggested initially by a user, validated, and then finally published. And after publication, it can be revised, or it can also be suggested for deprecation and then deprecated. There is also a desktop version that is still the original semantic TUC, stripped out of all the user management and other complex features for collaboration of VocBench, and it's just some user interface hosted on Firefox which can connect to the data server. So why should I buy VocBench? Well, first of all, the collaborative management. We have this workflow about type of application. We have a very fine-grained user management. You can have actions or series of actions which can be connected to users or group of users. You have a full editing history which can be accessed also through RSS, and fine-grained metadata and editorial notes. The tools, one of the contradistinguishing features from the very early age of the tool was multilinguality. So support for different languages, but also in the interface. Currently we have Dutch, Spanish, and English. Native RDF support, which is not always common in thesauri management systems. The scalability is limited only by the underlying key restore, so you can switch depending on your needs, and you can use completely open source and free solutions, or in most of the cases you need to embrace something more if you need something more. And extensibility, because we have these PostGI connectable services. Oh, and last but not least, obviously the system is free and open source. So a good reason for switching. Here we have a list, non-complete list of interested partners. These are the ones which are more completely now adopting or almost close to adopt VocBench. Some details about the evolution. VocBench2 will be almost ready in the next days. Since due to the origin of the tool, which, as I said, was initially built around AgriVoc and then progressively generalized, all the installation and the configuration steps were not so easy. So one of the most important features of 2.1 was covering the automatic installers and a framework for managing the DB and the updates, the DB schema, and so on. Oh, by the way, the system is natively using RDF. The DB is for other things like user management and REST. We try to preserve some aspects of the original system, and maybe in the future we'll move completely to RDF, but for the moment it is not necessary. As part of the model, we rewrite the RCS feeds to cover all of the editing actions, and multi-scheme management. So, just a few of interoperability and to some extent also scalability issues. First of all, dataset management. There are some set of operations which are strongly bound to the specific technology being adopted. As I was saying at the start of the presentation, my idea was to have a tool which is completely agnostic with respect to the specific people store being used, or even the middleware, so Gina or Sesame or whatever. The abstraction layer that we have provides as a first layer just an interface towards typical triple insertion and deletion operations, and obviously Sparkle. And then up over this tool we wrote some vocabulary, some API around this, the most common vocabularies of RDF, so all SCOS and SCOS Excel. And over this there is a component of semantic TUC which deals with import and recursive import and managing all the graphs inside the system. So there are some certain operations operations like creation, deletion, even the indexing, as we were talking before in the talk from on to text, that are still not invocable in a standard way. The indexing still needs specific SPARQL, the free text search still needs some specific SPARQL queries which are depending on specific technologies, or even specific queries for starting the indexing, which allows this functionality. There is a graph store API, which is still not so popular nor complete. So in most of the cases, it is not so easy to try to have this completely agnostic interface. Just a few words about SCOS. Okay, we are mostly covering SCOS Excel, and we deal with SCOS through import and export. That is, we just create SCOS Excel resources when we need, and then we kill them, and we make the system flat again, the model flat again when we export the information for those who are interested in purely SCOS information. What to do for the future, we still don't know. Probably it's just too complex to deal with too many kind of models, and probably the best thing is to end up the one which is most informative, and then just have this import-export. One problem with SCOS is that the only thing that is clear is that it is not clear at all. I understand that the necessity for having this shallower semantics with respect to out. Still, the problem is that many things are left too open, and this really hinders interoperability. I've seen the export of different tools, and sometimes the export of a tool is not usable by another tool. And it's not just a defect, it's just that, again, the standard is not clear. Also, one problem that we have is with multi-scheme management, because it's not easy at all to have a full management of schemes, to have concepts which might might be present across different schemes. This is not easy to manage at all, and we have not seen that the other competitors are dealing with it at a very advanced level. Okay, this is just very specific of our case. We are rebuilding the extension mechanism of semantic Turkey to add to allow for a more direct-to-business logic development and new functionalities. And the idea is to use a rich annotated Java code by means of dependency injection and aspect programming, so that the developers will be able to really focus on the things that they are doing and get most of the information for free. Most of the traditional coding that you need to retrieve resources or to access resources. Another aspect which is related to scalability, but at the level of an application, is the fact that if we take, for instance, many systems that exist now, and how they deal with extensions, so where with the possibility to access other resources. Usually they have projects, and then you access other data sets internally to these projects. This obviously doesn't scale. In a very collaborative environment, I couldn't allow a user to just enter the system and load a billion of triples just for doing his specific ontology matching project. So the idea is that we will have a complex multi-project system where each project might access to other projects requesting permissions, and there will be different level of users. Already there is a very fine-grained user hierarchy where there are administrators, ontology, maintainer, terminologists, and so on. The idea is to have even different level of administrations up to project administration, where these projects can be crossed each other and can be and the level of access to each project from each project can be defined. This will be really useful again in a collaborative environment where maybe we need to make different data sets interact with each other so that we can map them, even when we're dealing with big data in a collaborative environment. Another issue is reasoning. Okay, the formalities of how reasoning are clear, but where to store this information, how to store this information. You can see in the slide that we have a checkbox there telling show inferred and explicit information. The idea with VocBench is not to have separate boxes like, for instance, you have a protégé telling, okay, this is the tree of the classes and this is the inferred tree. The idea is that you seamlessly deal with explicit information which is inferred. The problem, again, is not in how to show it to the user, but how to access it. There is no standard for storing and accessing them. Each triple store does its own way. An inferred triple graph, for instance, or storing them in the default graph. And then you can access them with the inferred switch, but there is no way to access only the inferred triples without the normal triples. This depends on these are various approaches and depend on the triple store that you are using. And again, it's not a fault of the people making the triple store. It's just something that is not explicit. Again, another aspect which I really hate, the default graph mantra. I heard very often this sentence, like never use the default graph, or just use the default graph for storing metadata, which to me sounds like, okay, my finger is bleeding, cut it, so you won't have any problem in the future. The default graph is the unit graph that has no name, and in that sense is something where you can imagine that the main information is stored. The other graphs could deal with other aspects like important ontologies or whatever, but if you don't give a very explicit way of accessing its information, then you are really renouncing to the unique hook that you have for accessing that. And it seems that in Sparkle it is not possible to access directly this information. Yeah, thank you. So one last thing, what we would expect. This is one thing that all the previous things are mostly issues which are at the standard level. Here, this is something that we could expect from triple store reducers. Sometimes their products require dedicated customized clients. Or maybe they are mostly compliant with the existing clients, but they have some customization which is necessary to improve, to enable some of their functionalities, or to exploit some of their functionalities. Or sometimes they have light version of their triple store completely bundled in a component solution. Well, this is surely understandable also to not have them open source. But the idea is, if we want that people producing end user applications are exploiting also in a certain way, implicitly advertising their products, they should make them maximally accessible. Maybe that would be a solution, but any other ways, and redistributable. I think are two focus points that will enable a maximum, let's say, a broader, at least, distribution of these technologies, and also life easier for people using them. Okay, these are just references and links. VocBench is hosted on vocbench.uniroma2.it, but there is also a user community on that other side, aims.fl.org/2/vocbench2, and then there are user and developer groups. Same thing for semantic dark. Okay, and these are just a few relevant publications, obviously, not a complete list. So that's all, and if you have any questions in here.
It seems to me that you are asking a benchmark to cover the access control. Because, okay, the other complaints are not ones that can be readily addressed by a benchmark, but the access control just might be.
Yeah.
Okay? Yeah. So what would you like? Now, supposing that we have this publishing benchmark, for example, what kind of access control situations would you like to have this thing enforced?
Yeah, but you mean at the level of the project? Because, for instance, our idea was, okay, we could just postpone everything to just accessing a remote dataset. But the point is that we wanted that the mutual interaction between the dataset was explicit at the level of the projects. So, are you talking about some kind of access control list for projects?
I'm talking possibly about access control that depends on a named graph, or about access control that ties a principal to a named graph, or that you can join data from this graph with data from this graph, but not the other graph, this sort of thing, because typically you would use a named graph for contextualizing the provenance, or scoping things with projects.
Yeah.
So we could imagine that something of the sort might be, well, even encoded in the benchmark.
Yeah, sure. This is one of the things actually that I have in mind. The only issue that I see here is that this is not a standard. It's not no parsers, because okay, we would be the only one adopting it, or maybe it could be just seeing more positively. It could be just the first to trying to bring other people inside this approach. Because okay. Actually, the problem is that there is no standard for access control.
There isn't.
Right. So, yeah. So we are wondering what.
I think that one of the things that could be.
So what is your message to the LDBC?
Yeah, my message.
So then I mean, so basically we should kind of campaign to make that a standard, or.
Well, this could be really one possibility. I mean, there are a lot of things that I often think when I'm developing or I'm designing, and what I would like to always to say is, okay, apart from the vocabulary standards and the semantics, what should be the intended semantics of an application doing this, or what should be the kind of behavior? And it would be really nice, I think, to trying to standardize these approaches. For instance, when we were dealing with cross-scheme management, as I say, we conducted some investigation. There are not so many tools that are dealing very deeply with cross-scheme management, and all the actions that you may do have consequences, and then maybe there are side effects that you need to take into account. So maybe, yeah, I think that a sort of list of actions, side effects, and counter actions to be taken could be nice in evaluating an application. This could be a benchmark. Actually, it's more a functional benchmark than a performance benchmark.
Okay, thanks. With that drew over, I would like to thank you again and say that well, it's now coffee break.
Thank you.